Hi friends, in the previous video we have discussed how to find the equivalence resistance of a given electrical circuit. And now in this class we are going to discuss about the procedure to find out equivalence resistance of a symmetrical electrical circuit. What is a symmetry of electric circuit? Let us try to understand this. If you observe the circuit carefully, at the middle of the circuit there is a dotted line. If you put a mirror on this dotted line, the remaining part of the circuit will be shown on the mirror. So these type of circuits are called symmetrical circuits. Now let us try to understand how to solve this. If we try to find out the equivalence resistance of the half part, and we can easily find out the total resistance of the circuit. Let us try to find out the equivalence resistance of the first half part. So here all resistors are having same value, that is 4 ohms. And now let us try to take the first half part, and this part will be like this. This is the resistance of 4 ohms, and here this is the another resistance, and now here we have half of the resistance. And what will be the value? Let us suppose this is 4 ohms, and this is again 4 ohms, and this is also 4 ohms. And what about this? Here the value of complete resistor is 4 ohms, and here we are taking the symmetry. That's why its value will become half of this. That means if it is 4 ohms, this will become 2 ohms. And if you observe carefully, these two resistors are in parallel connection. So 2 ohms and 4 ohms. Let us try to find out the equivalence resistance of this part. And we know the formula to find the equivalence resistance of resistors in parallel connection. That is 1 upon R equivalence is equals to 1 upon R1 plus 1 upon R2. Let us substitute the values. 1 by 2 plus 1 by 4, and this becomes 3 by 4 ohms, and then our equivalence is equals to 4 by 3 ohms. And now we have calculated the equivalence resistance of this part, and now the circuit will be changed like this. This is point A, and here we have a resistance of 4 ohms, and here we have another resistance of 4 ohms, and now this part will become like this. The third resistor, this is of 4 ohms, and this is also of 4 ohms, and this we have calculated just before, that is 4 by 3 ohms. And now if you observe carefully, this and these two resistors are in series connection, both 4 ohms and 4 by 3 ohms, and we know the value, we know the formula to find equivalence resistance of series combination, or equivalence is equals to R1 plus R2. So if we substitute the values, here we have 4 ohms, and plus here we have another resistor of 4 by 3 ohms. If you simplify this, we get 16 by 3 ohms. And now the circuit again changes like this. See, we have the 4 ohms resistors as usually, and now this part has been simplified and this will become like this. This is 4 ohms as usual given in the circuit, and this value we have calculated just before, that is 16 by 3 ohms. And now if we observe this circuit, these two resistors are in parallel connection, and if we find the equivalence resistance of the parallel connection, this will become, so 1 by 4 plus 1 by 16 by 3. By simplifying, we get 1 by 4 plus 3 by 16. If we simplify this, we get 16 by 7 ohms. Sorry, 7 by 16 ohms. Now this is the value of 1 by R equivalence, and we want R equivalence, that is R equivalence is equals to reciprocal of this one we need to take, that is 16 by 7 ohms. So this is the equivalence resistance of half of the circuit. And as this is a symmetrical circuit, we have calculated the equivalence resistance of first half, and if we want to find the total equivalence resistance, just we need to multiply the equivalence resistance of first half value by 2, that is, so 16 by 7 into multiplied by 2, so that is equals to 32 by 7 ohms. So like this we can easily calculate the equivalence resistance of the symmetrical circuits.